Hi, welcome to another podcast on lead-acid batteries. In today's Q&A session, we have Ramesh Natarajan, a veteran with over 42 years of hands-on experience, having an insightful conversation with a guest who is asking him a lot of technical questions. Hope you find this podcast useful to your business. Do visit www.rameshnatarajan.in to stay connected.
Hello and welcome to today's episode of my podcast. Today I have Mr. Avnish Arora, a dear friend of mine, with me. He has a vast experience in marketing and sales on the all India level in the field of batteries and related equipment. He was associated with HBL, a large and reputed company based in India. He worked there for 25 years at a senior management level and directly reported to the managing director till he retired on 31st December 2021. Though he was handling marketing and sales, he has a lot of knowledge about production, process, projects, vendor development, servicing, and other related areas. He has in-depth domain knowledge with experience in key industrial segments of telecom, railways, data centers, large industrial UPS systems, and EVs, to name a few. As the founder director of ASAP Engineering and Consultants, he is currently helping companies with strategic marketing of advanced electrochemistry to niche customers. I have been in regular touch with Avnish ji for many years, and an earlier podcast of ours has got fantastic reviews. We therefore decided to do another podcast today on stationary batteries. Avnish, you can now proceed.
Sure, sir. Sure. Thank you so much, sir. I am humbled and honored to have another podcast with you. And I am also happy to learn from you that the last one did well.
Yeah, very well, in fact.
Thank you so much. So, in this particular podcast, sir, I wanted to understand from you, and rather, I would like to discuss with you about stationary batteries and the reasons for failure of these batteries in service. So many times we have heard from our customers, from our users, that the lead acid batteries in service die a sudden death. There is suddenly there is a failure, and when they get the battery checked from the electrician or the technician or the service engineer, they say that no, there's no life left in that. So it is a very kind of surprising phenomena for a user which is using these batteries for applications like inverters at home or with UPS systems in their offices, clinics, hospitals, shops. So they get a little disturbed, alarmed when they come to know that, okay, suddenly the battery has died. So what is your, what will you advise, what advice you will give to these users, and what kind of maintenance practices they can adapt to avoid such failures?
See, one thing, when you talk of sudden death, mostly the sudden death thing comes with usage of a pasted plate or automotive battery, which people are not aware of. So first and foremost, what happens is in these homes and small clinics or a small hospital or a shop, people are not very much aware of tubular, and even if they are, unfortunately what happens is these small dealers and shopkeepers who sell these batteries, they many a times when there is too much of haggling on price or something, they give a battery which is an automotive battery which is not to be used. So first and foremost, the sudden death comes mostly with those batteries. If a tubular battery is fitted, what happens is generally the backup keeps on reducing And then they find that what backup they were getting of about 3 hours, 4 hours earlier, over a period of time it's 2 hours, and later on it's about half an hour, and then it is dying. So there it is a comparatively slower sort of decline in performance. Okay, these are two things. And I liked your question, because what happens is you're saying of you specifically mentioned about home inverters, UPS systems in clinics, hospitals and shops, because such problems do not generally crop up in industries or large organizations where the batteries are periodically maintained by trained personnel. Right. So the segment that you are talking of is mainly these small shops or small clinics or homes where these problems crop up. But irrespective of whether it is a home or a big organization, the possible reasons in case there are problems with batteries, and especially if they are tubular batteries, where we are not talking of this sudden death, the possible reasons for complaint are, basically related to overcharging, undercharging, insufficient electrolyte, overfilling, loose contact or corroded terminals, over discharge, incorrect sizing of the inverter, improper matching of the battery and inverters, impurities in the electrolyte, high temperature operation, or breakage of the containers. So now we will go over these various reasons one by one. I'll just explain to you what happens if there is overcharging, what happens if there is undercharging and insufficient electrolyte and all that. See, when it comes to batteries, and suppose there is a overcharging of the battery, what happens is it's not good for the battery, because in case of an overcharging, what happens is the temperature goes up. There is a excessive gassing also because of that, and when there is excessive gassing, there is a loss of water. So water addition has to be done frequently. And because of the increase in temperature, because now the overcharging causes the increase in temperature, because of which there is degradation of components. What you have inside a battery is positive plates, negative plates, separators, certain plastic components. All these get degraded. And once they get degraded, naturally the performance is going to be not as it was planned to be. And if the water content keeps going low and low, that is also going to create problem. What happens with overcharging is, in the case of positive plate, the grid gets overformed and corroded. Even if the positive plate is having the active material encased in a tube, the current which flows through the grid, it overforms the grid and the grid gets corroded. And that's how the positive plate gets damaged, even if it is a tubular battery. In the case of negative plate, they are having a pasted material on it. The active material is pasted onto a mesh-like structure. In that case, what happens is the active material gets loosened and you have the active material falling out. Once the active material comes out of the plate, and then there is a possibility of shorting from below, and that is how the life of that particular cell is over, and then you have the shorting creating problems, and then the battery gets damaged. Of course, all this doesn't happen in the very first month. Whatever I'm telling you, these possible reasons for complaint, you may have a combination of overcharging and overfilling, or over discharge and all this, or any one also can be the cause. But usually a combination of all this creates the problem, and that is how the life comes down. In the case of undercharging, what happens is the plate starts buckling, because lead sulfate, which is the active material in the positive and negative plate, that occupies more space than the PbO2 and Pb. So when you keep a battery continuously in a sulfated state by undercharging, the plate starts buckling and then the active material falls off. And in one more thing which happens because of consistent undercharging is, one or more of the cells of a battery gets exhausted, and that becomes a lagging cell for that battery. So compared to the other cells, this cell is not able to give the required current because it is always lagging. The specific gravity is low, the voltage of that cell is also low, and whatever the power is demanded by the load, it requires the volt into ampere. Wherever the voltage is low, the current has to be delivered more. So unfortunately, the cell which is undercharged and lagging has to deliver more current, which is ironic because the cell which is stronger is delivering less current and getting away with it, but the cell which is undercharged, having a lower voltage, has to deliver the higher current. So the result of consistent undercharging is this cell also faces a problem.
Sir, as a summary, what you said just now is that if we do overcharging, there is the cell
Gets damaged.
And it can be shorted.
Yeah, because it's getting heated up.
It is getting heated
up and also excessive loss of water.
Yes. And if we are, if the cell remains undercharged, then it becomes lagging and it can pull down the entire battery bank and
it has to give more current which it cannot give because
yes.
So both these are bad.
So you are saying that overcharging is also bad and undercharging is also harmful.
Yeah, both are
for the battery.
Yeah.
So there must be some range or some check and balance or some recommended range where the charging has to be done.
Yeah, see what happens is when we talk of a UPS system or an inverter, the battery is not used on a daily basis. So these batteries are kept on a float voltage. What happens is the float voltage is generally recommended to be 2.16 volt per cell to 2.20 volt per cell for a flooded electrolyte. And in the case of sealed maintenance-free batteries, it is 2.25 to 2.27 volt per cell. Now, why is this kept floating at that voltages? Because there are some self-discharge losses, which is an inherent property of the lead-acid battery. You may have, in the case of flooded electrolyte, you are also topping up. So you may have certain impurities getting in the topping up water, and there can be self-discharge losses due to that also. So to compensate for these self-discharge losses, there's a trickle current which is going from the inverter or the UPS system, which keeps it on a certain float voltage. Now the float voltage has to be as prescribed, as I mentioned to you, and if it is higher due to a fault in the inverter or something, it will end up overcharging. Right. Now after a discharge of the battery, what happens is the battery has to be fully charged. So the battery goes to a full charge state, which is a boost mode, and then after it has reached the required voltage, the voltage setting goes to the float mode. Now if there is a fault and it remains in the boost stage without going to the float stage, right, that means it is going to a gassing voltage or beyond the gassing voltage, in which case the battery will get damaged. So this is a characteristic of the inverter or the UPS, and so overcharging happens only because of the UPS. At the same time, undercharging happens also because of that. But if the UPS is new and not problematic, battery won't have a problem. But if you're facing this problem, people sometimes say, oh, battery is giving a lot of smell, there is some acid smell coming and there is a problem. Then they have to call the inverter guy and check it, or call the battery guy and he can also check that the voltage is high and it is not getting into the float voltage mode. So this has to be observed and done, and both overcharging and undercharging can be taken care of. It is just like humans, if we are obese and overweight, then we get into fatigue faster, we have our organs getting damaged. And so similarly, if you're underweight, then you don't have the energy to perform your daily activities. So you have to eat right and be fit. Similarly, here the voltage, the current and all these settings have to be right and the battery has to be fit. So that is the way it is when it comes to this.
Right.
As far as we go to the next possible reason for a complaint, which is insufficient electrolyte. Now, in the case of sealed maintenance-free batteries, okay, there's no electrolyte topping up required, which is why they call it maintenance-free. Okay, I have, written an article on how maintenance-free battery, though they call it maintenance-free, actually it's a misnomer. It's not maintenance-free, it's maintenance not possible battery. But that's a different thing. But when you're using a maintenance-free battery, so-called maintenance-free battery, you don't have to do a topping up. But then if you're doing a flooded electrolyte battery is what you have, then you have to top up periodically because the water component of the electrolyte goes off and that has to be replenished. So this has to be topped up to the correct level, and you have to ensure that this is done periodically. And if it is not done, if the topping up is not done properly, what happens is there is insufficient electrolyte in the cell, because of which there can be an abnormal sulfation, because the top of the plate from which the electrolyte goes down, that part of the plate is not taking part in the reaction. So you have a plate of say 50 ampere hour, and if the top portion is not taking part, then the portion taking part is only a 30 ampere hour of the plate, and that 30 ampere hour of the plate has to give the high current. So naturally that is getting loaded. You want the entire plate to take part in the reaction. Another thing is lack of heat transfer from the plates is also another possibility. The cell starts getting heated up because it is not having sufficient electrolyte. In such cases, do not ever add acid and make the cell more concentrated with sulfuric acid. You have to add only water, and that too it has to be only distilled or demineralized water.
Right.
Then like I mentioned, overcharging, undercharging. Now again, insufficient electrolyte is bad, but overfilling is also bad. Why is overfilling bad? We may feel, okay, I'm just adding a bit of water extra. What does it matter? But no, the extra water you're adding takes a part of the electrolyte and goes out.
Mm-hmm.
And when that electrolyte goes out, what happens is you are having the gravity of that particular cell coming down.
Right.
When the gravity is down, the voltage of the cell is down.
Right.
And compared to the other cells where you have filled properly, the gravity in the cell where you have filled more is lower. So overfilling is also not a good thing. And another problem with overfilling is it causes overflow of electrolyte, leading to ground paths and thereby the loss of cell capacity because of the reason which I mentioned to you. And so that overfilling is not good also. In fact, I have done a separate podcast only on overfilling, and that is there on my streaming platform. So if somebody wants to understand only about overfilling and how much of a problem it creates, that podcast is anyway available. And the next one is over discharging. Over discharging is also not good, because when the battery has to be recharged, and if it has been over discharged, the electrolyte specific gravity goes down so low that the conductivity is lost. And so reviving of a battery which has been over discharged becomes difficult. That is why sometimes you see that the service engineer or a shop owner from a battery or service guy comes and he says, "Sir, I'll take this battery." Then he takes it back. He tries to revive it. He finds he cannot revive. Then he has to add a little acid. And then when he adds the acid and makes it a little conductive, the voltage starts coming up. But what they don't realize is when they have added the acid, they have to also remove the acid and equalize the gravity to the final gravity. They leave the extra acid inside, and that creates more problem. So that should not be there. So we should not over discharge, because that creates a problem of a low gravity and inability of the battery to get recharged because of the low conductivity due to the low specific gravity of acid. We go to the next problem, which is loose contact due to corroded terminals and cable joints. In this case, what happens is, if there is a loose contact and when you are drawing a large current, the battery is not able to deliver this high current because the sparking, the loose contact, and the resistance for current transfer at the point of contact of the terminal with the cable. Because products of corrosion are non-conducting substances, they prevent the battery from delivering large current, and they make the resistance too great for the passage of these large currents. So you have a problem because of that also. So periodically when these batteries are being maintained, one has to see that the terminals don't have this sulfates formed there, and you see it like, because you use copper cables and brass terminals, sometimes you have copper sulfate crystals formed at these contact points, and those need to be removed, cleaned, and you have to put Vaseline there and ensure that these are tight fitting. And in case some corrosion has taken place, probably even the connector or terminal may need to be changed because if it is badly damaged.
Yes.
The next thing is incorrect sizing of battery. This is another problem. Sometimes you buy an inverter and a battery, and the battery comes with a 200 Ah capacity, and later on when you want to change the battery after a period of say 3 years, 5 years or whatever it is, then you find that okay, this 200 Ah battery is very costly, and many a times the shopkeeper or the person who is selling the battery, he doesn't want to lose you as a customer. He says, sir, you take a 100 Ah, both are 12 volt, you won't have a problem. Well, it's true that the inverter is a 12 volt inverter, and a 200 Ah is giving you more backup, and he will tell you 100 Ah may give you less backup, but anyway, compared to the 200 which is old and giving you half an hour, this will give you at least 2 hours. It may not give you 4 hours backup, but you take this and all that. So you end up buying a 100 Ah battery and fitting it to the inverter, and you start using it. But what the person who sold the battery to you, or either because of his ignorance or maybe because he wanted to make the sell, what he doesn't tell you is the charger of the inverter is meant for a 200 Ah. So it starts charging this 100 Ah battery at that high current, and it starts heating up this battery.
Yes.
And that also creates a problem. So an incorrect sizing of a battery or a wrong battery fitted to an inverter of an undersized type is not good. Not only it gives you insufficient backup, but because though the battery voltage is matched, you have problems due to heating up of the battery. So incorrect sizing of the battery is also not a correct thing. So you have to always match the battery and the UPS. Then sometimes the reverse also happens, of course. You have a 100 Ah battery and an inverter. Now the power breakdowns are more, the duration of power breakdown is more. So many times you go and tell him, I want more backup. Now if he wants to sell you an inverter and a battery, he finds it difficult. So he says, okay, you are using 100 Ah, you use a 200 Ah battery, you will get more backup. You will get more backup, but the time required for charging that battery also is going to be more. So your battery will not get recharged properly. So you will always have an undercharged battery, especially if you're using it frequently. Okay, if you're using it today and 4 days there's no power shutdown, and then the battery has got charged, it's okay. But the main reason why you have gone to him is the power shutdown is more. It is for a longer duration, and you have gone to him. So the first 3, 4, 5 days or maybe 10 days it works because it's got sufficient power. But over a period of time, you'll find that the battery is continuously remaining in a undercharged state. So the matching of the battery and UPS is very important because of that. And one more case of the improper matching I'll tell you. Suppose you are having a flooded electrolyte battery, and your inverter is also made for a flooded electrolyte battery, and it is meant with a float voltage of 2.16 to 2.20, and then you go and say, oh, I don't want this problem of putting water periodically, I don't want to give you an EMC and all that, and then your person, I have to keep following up. So you do one thing, give me a sealed maintenance. He'll fit a sealed maintenance. Now the float voltage is not matching because the inverter is set for 2.16 to 2.20 float voltage. Right. Your maintenance fee requires a 2.25 to 2.27. Again, you will have a problem because of the incorrect float voltage. So this is a very important aspect, though it is often not understood in that manner. Next, we come to impurities in the electrolyte. Again, in this matter, it's a topic by itself. I have done a full podcast on impurities in electrolyte and the purity of water which is required for topping up. But I'll still touch upon some points, like what happens is when you're putting water, you may have demineralized or distilled water, but suppose you're using a metal can or something, the metal can may have impurities, or if it is something made of iron, then you may have some iron particles going in along with that. So one has to ensure that the vessel used in which the water is stored or water is taken for putting into the battery also has to be good, because if iron gets into the battery, it is oxidized at the positive and reduced at the negative, and it discharges the positive as well as the negative. You see, the positive and the iron, the negative and the iron, they make it a local cell sort of reaction and both get discharged. And if there is manganese due to some reason, then it bleaches the separator and eats away the rubber separators in case it's rubber separator, or attacks the separator. Chlorine also bleaches the separator and it also releases antimony from the positive plates. At times you have some bleach or ammonia or something in the bathroom or toilet, and you have used a container and used bleach or ammonia or something, and later on, okay, you just superficially wash it and then use the same container for topping up, then ammonia also causes self-discharge of both the positive and negative plates. And of course, alcohol gets oxidized to acetic acid and it causes corrosion of the grid metal. I don't know if somebody will use an alcohol, but it is also a possibility. You cannot, it is not recommended, yes. And I hope they don't use it. Then we come to high temperature operation. Now, high temperature operation is basically because of overcharging, and I've already mentioned to you, like, it degrades the battery components, and any temperature above 55 degrees is very bad. And in high temperature, the rate of corrosion, the solubility of the metal components, and self-discharge, all these are accelerated, and so high temperature operation is not recommended. Right. Lastly, we come to a cracked or broken cell container or a broken battery container. These battery containers earlier used to be of hard rubber. Nowadays, plastic is used, and batteries are not so heavy. But despite that, at times when shifting, either somebody shifting home or shifting the inverter from one portion to another place, another room, or maybe to a balcony, to a loft, or all these things happen. And many a times you have a small crack or some damage to the container, which is not very easily noticeable, but it can lead to leakage of electrolyte. And if the electrolyte from one cell is continuously going down, and if such a thing is noticed, people many a time say, okay, I'll keep on filling water, it doesn't matter. But you may keep on filling water, but the cell specific gravity of that particular cell is continuously dropping. The electrolyte is becoming diluted. The specific gravity, when it goes down, the voltage goes down, the cell capacity diminishes, and over a certain period of time, the plates get completely sulfated, damaged. And so this is also not something which should, we have to take care of all these aspects.
Absolutely.
So these are all the major things which we need to take care of.
Sir, very enlightening session and explanations which you have given, especially the cracks which sometime occur due to shifting of the cells at home or at shops or clinics. Yeah. So that is a very important thing which needs to be taken care of. And all other things like overfilling and underfilling, and basically if we keep a periodic check of all the things which are recommended for a smooth operation of the battery, it won't be a problem. Yeah. So thank you very much. And if all these things are taken care of, the battery shall perform well without any problems.
Yes, but I'll still talk about some other reasons for problems on site also. Okay. Like, suppose the battery has not been commissioned properly.
Right.
Then it can create a problem. So nowadays, of course, companies are delivering to the dealer or the distributor factory charge batteries because of that. So these problems have reduced to a great extent. So I did not touch upon it. Another thing is, of course, you can't keep a battery in a dusty or dirty environment. Usually batteries are very costly. Industries and organizations, they realize the value, and there you have large systems. So they have battery rooms. They take care of the batteries in a proper manner. But I have seen sometimes in these small clinics or small hospitals and all, they generally keep it just out in the open and all that. And that is not a good thing to do, because if you have it in a dusty or dirty environment, then you have the tops of the batteries also. Sometimes they are even exposed to the rain, in which case, and vent plugs are open, rainwater can also get in. So it's not a good thing. Another thing is insufficient ventilation is also bad, because suppose due to some reason you have an overcharging, then you have a lot of hydrogen being evolved, and that is explosive in nature. So insufficient ventilation is not a good thing. It's always better to keep a battery in a well ventilated environment. Then if the charger is damaged, you can have a high ripple voltage coming from the charger. Okay. But then this is not very easy for anybody to find out unless the inverter is very old or something. These things won't happen because the chokes and filters will take care of it. But if you're having an inverter for about 20 years or so, and then you're only changing the batteries periodically after 3 years, 4 years and all that, it is worth getting the inverter also checked, or straight away changing the inverter, because later on, even if you put a new battery, you can have a situation where the inverter is faulty, because of which your battery life is gone. Then there are sometimes contamination from surrounding environment also, because I've seen in small restaurant type places also, they use batteries nowadays for backup power, where you have place for about 10 people to sit, and it's a small tea shop or something like that, a snack shop. There you have a lot of contamination also from the surrounding environment, yes, because of which the battery can get damaged. Another thing is unsafe handling, or many a times battery terminals are exposed and people just keep something on the battery, and if it is metallic or something, it can lead to an explosion or fire, and that's also. So these are some other problems which I've seen on site. Of course, this is not so common. So the most common and the most important things I've mentioned, and these are some additional points.
Right. Thank you so much, sir. So maybe in the coming time we will engage in more
detail on some
other topic.
yeah,
like
sure.
Solar inverters is the
it's the in thing now.
Which,
Yes.
and how the batteries remain under charge by using solar inverters, or get overcharged by using those inverters. So that
is another. We can surely do that also. Of course, nowadays there are some solar systems which don't require battery, like the rooftop solar, but that's a topic by itself. Then there's a hybrid system. Yeah, we can get into that also some other day. Sure. Thank you, Avnishji. It was a pleasure.
My pleasure.
Always very nice talking to you and interacting with you.
Absolutely.
Thank you, Avnish.
Thank you.
Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.